Hi, if you are watching this, you're probably wondering why and how cobots can work for you. So let me cover the main aspects and some tips of the lean robotics methodology that will get you started. At Robotiq, based in Quebec City, we build end effectors, tools, and sensors that free human hands from repetitive tasks. We work with a very wide range of end users, from global manufacturing leaders to smaller enterprises, and you are probably wondering where do you stand in there and how can it benefit your industry. The idea is to trade manual labor to engineering. Basically, we want to use our heads to create automated solutions that will free human hands so that they can focus on more, I would say, value-added tasks. You want to be investing in easy-to-use platforms because you want to be up and running quick enough. You want to be able to use standardized items, reuse components, and you want to minimize customization. And finally, you want to build, share, and create an internal skill set and know-how. And the cobot is not the main challenge in all this. You can order a cobot, get it in a couple of weeks, plug it in, and program it to do a simple task in a matter of minutes, really. The whole challenge in there is the application itself, because that robot will have to interact with other users. You'll need to program it, you'll need to maybe connect it to other machines. In feed, you'll have to think about out feed, training, upgrades, and so on. So the challenge is the whole application. And to get you there, because it is a project management task, we have developed the Lean Robotics methodology. Now, this book was written by Sam Bouchard, our CEO, based on his experience after working with a lot of manufacturers worldwide. So as you may expect, it is an extension of the lean manufacturing methodology. It does focus on the customer value. It does focus on eliminate the waste along the way, as well as on continuous improvement of the robotic cell. So I won't go through all this book. You can easily get a copy by visiting leanrobotics.org. There's hard copies, there's PDF copies. You can get it as an audio book as well. What we'll do today is I'll do an overview of the process, as well as some hints that will help you out on your first robotic project management. So the book itself is a step-by-step guide of project management tools, and it really takes you from A to Z, from how to get started, as well as how to eventually operate the cell, monitor it, and even scale for further robot development in your plant. The way it is split is in three main phases: a design phase, an integrate phase, and an operate phase. The design phase starts with understanding the manual process that is to be automated. Then we'll start working on a robotic concept and eventually design the actual robotic cell. So the outcome of the first design step is the plans and equipment for the robot cell. The second main phase is the integrate phase. It starts when you receive the material and start actually building the cell. So you'll want to start with preparing the cell or assembling the cell offline, and then you'll want to be preparing the production line, so that it's compatible with the cell that is coming, and eventually install it on the actual production line. Then there's going to be some training to do. You'll want to train your staff. You'll want to think of who has to be trained and on what, and so on. And the output or the outcome of the integrate phase is the actual robotic cell and team that are ready to operate. Then comes the operate phase. Now the robot is running, running production. So you'll want to turn on the switch, of course, and then start monitoring, troubleshooting, maximize uptime, maximize efficiency, focus on KPIs, and improve them with time. So where are you currently standing with all this? Where are you? Where do you stand in your lean robotics journey? So if you're watching this, you're probably already committed, or your organization is already committed to continuously improving the processes and tasks. You're probably already standardizing work processes and already have an automation strategy. If robots are part of your automation strategy, then lean robotics is definitely your next step. And this is why choosing the proper KPIs or key performance indicators is so important. You have to ask yourself, what are you trying to improve? Do you want to improve capacity? Do you want to improve quality, first pass yield, for example? Are you working on efficiency, cost per part, or so on? This exercise will have to be done, and is one of the very first steps. And before heading into design, you'll have a couple of preparation steps to think about. So you'll want to build a team that is ready and has the right skills to do the job, right? To pull off this project. So you'll have to identify the roles and assign the right person to each of those roles. Then you'll need to target the right project, because some projects are more, I would say, suited for cobots than others. Then you'll need to gather the stakeholders, involve everybody that has that this project will impact, and communicate the vision throughout the organization. So here are a couple tips that will help you out along the way. Tip number 1, start simple. We can never stress that enough. So we have developed a graph that will help you to, I would say, sort the potential applications that you might want to be working on. On the vertical axis, you can arrange them from simple to complex. And on the horizontal axis, you can sort them from having a low impact on your organization or having a high impact or a higher return on investment or benefits. The first ones you want to start with are definitely the simple applications that have a high impact for your organization. Your first project should be one of those. Once those have all been done or addressed, then you can start working on projects that have a lower impact or lower return on investment, as long as they're still simple, because the idea is to build the skill set. And keep in mind that the robots can be repurposed later on. They can be reused. And are well suited for continuous improvement. Then, only then, can you start working on more complex projects. Once that your organization has done a couple projects, you have an internal skill set, internal know-how, then you can start working on more complex projects, as long as they are high impact projects. And when you start figuring that an application is going to be complex or more complicated or sophisticated to do and still has a lower impact for your organization, then you definitely want to look at another automation solution. Then cobots will not be suited for those types of applications. By focusing on starting simple, as a manufacturer, you'll be entering what we call the virtuous circle. By using a less complex project to start with, this project would involve a lower cost, right, and probably a quicker timeline, which in turn will probably involve a higher return on investment, right, because you were working with a smaller, more simple projects that have a lower cost. This will justify the next steps of using or purchasing more robots for your organization. And eventually, every time you go through a robotic project, your internal organizational skill set will increase, will improve, making the next projects less complex projects, right? Because you already have the skill set. And then the loop or the circle goes on. So I hear you say, okay, I want to start simple. That's fine, but what is simple, right? Because what's simple for a robot and what's simple for a human are two different things. So I would say one key concept to keep in mind is that robots are motion repeating machines. So think about this all the time, motion repeating machines. So here's still a couple of examples and a couple hints. First of all, let's look at the most common tasks for cobots. Pick and place is something very common. Assembly, just putting parts together, is very common. We see it all the time. Same thing for machine tending and finishing applications. So then, if we break it down, what is easy, what is hard? So moving around, picking and placing a part with no force involved or nothing else involved is easy. That's easy. And if you have to add force or guiding in there, for example, grinding or sanding, or whenever polishing or force is applied, then it becomes a harder task. Now if we look at the parts themselves, of course it's going to be easier for the robot if the parts are always the same, or if the range or the different number or different models of parts is limited. And it's going to be harder, of course, if it has to work with a wide range of different parts of different shapes and sizes. And not only the parts themselves, but the way we present it to the robot can have an impact on the project. So of course it's easier for a robot to always pick a part at the same place, right? If it's on a tray or on a jig and it only has to go always to the same place, right? Repeating motion, repeating machine, that's going to be way easy. If you want to present them in a tray or in a different order every time, now it becomes more and more complex until you reach very hard applications for a COBOT, such as bin picking or a fast moving conveyor. Remember, the collaborative robot, by its collaborative nature, is not meant to move so fast. So fast moving conveyors are definitely not a starting point, especially as a first project. Now, what makes programming easy or hard? Well, think of the different scenarios, different possibilities. Okay, a simple repetitive task that always does the same thing is very easy to program. Now, when you start adding multiple conditions or inputs or logics, then it becomes harder and harder to program. One other interesting thing or consideration to keep in mind is that it's easy to work with things that are meant to work together. Think of your smartphone. It's got an embedded video camera, microphones, speakers, and so on. And the apps out there will use all of those easily because they are meant to work together. Now imagine doing the same things with equipment from 20 or 30 years ago. Putting all this together that are not meant to work together would be quite a challenge. Tip number 2. Keep it simple. Remember, we wanted to start simple and then keep it simple. Focus on the minimum viable cell. So focus on the simple design that will bring benefits to your organization, and then stick to it and get it done. That's basically what we're saying here. Because the cell basically has zero value unless it is running and operating. So think of a simple enough task, get it done, and forget about the nice to haves or the add-ons or might as wells, or might as well do this or might as well have it do that, and so on. So those nice to haves can be considered in later phases and continuous improvement, but you definitely want to start with something simple and keep it simple until it is up and running. This overview of the process is a good way to bring our third advice. Design is not the starting point. Remember, the manual process definition is your starting point, and what you need to keep in mind is the goal. Why are you automating? It's very easy to get excited and think, okay, I want this robot, I want that sensor, that gripper, and so on. But then the design and the technical advantages or considerations shouldn't be what drives your project. The end goal of the manual process improvement should be what drives you. So tip number 3, design is not the starting point. Tip number 4, know yourself. And guess what? One of the key ingredients into successfully deploying your first robot cell is knowing the manufacturing process. And you are the best suited person. You are the one that knows this process. So you already have one of the 3 main ingredients. The other 2 being the robotic skills as well as the robotics project management skills. And guess what? Both can be learned, both can be worked out, and they actually are the core of the Lean Robotics book. So with all this, you have all it takes to successfully deploy your first cell. Tip number 5, invest small to remove big risks. Technical challenges for a robot and for a human might be different, okay? So you want to list what could possibly go wrong with the design, come up with an hypothesis, and then a confidence level, whether you think that it's feasible or not. And then for everything that is critical, you'll definitely want to either think about how to validate it and how much will it cost to validate or to test it. So you can request proofs of concept, you can do some tests, you can look at what other people have done, look at case studies, look at read on forums and so on, but you'll need to de-risk at some point. So that's our tip number 5. Tip number 6, especially in this time and day where we need to get up and running in a quick, efficient manner, standardize. Standardize and try to avoid custom engineering. There's a tool out there that is meant to do anything or almost anything you might think of. So go ahead and use them. They can be reused later on. But yeah, you really want to standardize as much as possible what you are using. This takes us to tip number 7. Include design time in your final payback calculation. The goal of this method is to simplify and streamline the Robotiq cell deployments. Here's a timeline of a typical project with a lot of wasted time along the way. The impact of waste in design and integration is that the Robotiq cell will start production later. What's the value of 2 months of robotics production, and how long does it take to regain that loss? So we can clearly see the impact of waste in the operate phase, like long changeovers or other sources of downtime that are pretty obvious. And by using this method, you will have the right Robotiq cell starting to produce as early as possible. And once it will be in production, it will only produce more. And last but not least, tip number 8, groom your robotic skills. That's a dirty little secret in there, because as well as it can solve your manual skills shortage or increase capacity and productivity, it could potentially create a bigger challenge, right? Because you have to stay up to date with all the technical consideration that using cobots involves. The good news is it's pretty well documented, and there's a lot of resources out there, especially for cobots. And more manufacturers start creating intuitive, easy to use tools. So that's the good news. The documentation is out there, the resources are out there, and you can pick it up fairly easily. So here's a final thought before we wrap this up. What you see here is a picture of Sam, our CEO. That's 30 years ago. And if you see, you'll notice the keyboard of a Commodore 64. So for a lot of kids of this generation, this was our first encounter with a computer, right? What about today's kids? What are they fascinated by? What gets them excited? We notice that things don't change much, right? Slush puppies is still a thing, and the kids are still interested in technology. So cobots are pretty much the easiest way to have robots working in your factory, and having robots in your factory are definitely a good way to have the younger generation work for you and be excited about it. And this is pretty critical for the future of your company. So again, how does this fit in your current business, and what is your next step? So if you are currently committed to continuously improving your tasks and processes, you are engaged with the management to standardize the work and processes, and you have an automation strategy out there, and by defining this strategy you are looking at introducing robots to your company, then your next step is lean robotics. So your very next challenge is going to be to target or to identify the very first process that you want to automate.